Welcome to the AI for Career Success video overview by Kurt Robbins, where we help you get smarter than your competition. Today, we're diving into the incredible high-stakes battle to build the brains of the future. And we're basing this on some fantastic analysis from outlets like CNBC. So, let's start with a really basic question. Who's actually building the brains behind all this AI? It sounds simple, right? But the answer is super complex. The entire AI revolution, we're talking everything from your favorite chatbot to self-driving cars, it all runs on these unbelievably powerful, specialized computer chips. So let's break it down. To really get a sense of the stakes here, just look at this number, $3 million. That's what it costs for just one server rack packed with Nvidia's latest and greatest Blackwell GPUs. And get this, they are shipping 1,000 of these racks every single week. This isn't just some tech race, it's an absolute economic tidal wave. And right now, Nvidia is without a doubt the king of this whole new kingdom. I mean, they've just rocketed from being mostly a gaming company to becoming the absolute heart of generative AI. So how did they pull that off? Why is their tech so perfectly matched for this exact moment in history? Well, it all comes down to this, the GPU, or graphics processing unit. Think about what it takes to render a video game. The chip has to figure out the color and position for millions of tiny pixels all at the exact same time. That's called parallel processing. And it just so happens that this exact skill is what makes GPUs the absolute workhorse for training enormous AI models. The real turning point was back in 2012. Some researchers took a regular gaming GPU, used it to power a neural network called AlexNet, and it totally smashed all the records for image recognition. That was pretty much the big bang moment for modern AI. Now, GPUs dominate everything, from training the models to what we call inference, which is actually using the AI. And Nvidia is not taking its foot off the gas. Their next-gen chip is already in the pipeline. But you know how it is in the world of tech? No king gets to reign forever without some serious challengers. And funnily enough, the very companies that are Nvidia's biggest customers, we're talking the biggest tech giants on the planet, are now starting to become their biggest competitors. And they're building something very different. They're building these things called ASICs. That stands for Application-Specific Integrated Circuit. So unlike a GPU, which is designed to be a general-purpose powerhouse, an ASIC is custom-built and literally hardwired to do one specific job, and only that one job, with mind-blowing speed and efficiency. Now, this analogy is just perfect. Think of Nvidia's GPU as a Swiss Army knife. It's super versatile, right? It can handle all sorts of different AI jobs really, really well. An ASIC, on the other hand, is like a dedicated bottle opener. It does that one job perfectly, way faster and better than the one on the Swiss Army knife, but you can't really use it for anything else. That's the big trade-off. Do you want flexibility or do you want hyper-specialized efficiency? And just look who's building them. It's a who's who of big tech. Google was really the first mover here with its TPU. Amazon's got Trainium, Meta, Microsoft, even OpenAI are all in the game, developing their own custom silicone. And why are they doing this? Well, it's to cut down on costs, get more control over their own destiny, and, of course, to rely a little less on a single supplier. What's really cool is that each company has a slightly different philosophy. Google's TPU is kind of engineered like one massive, rigid system, almost like a single huge factory conveyor belt that's specialized for these enormous, complex math problems. It's incredibly powerful, but maybe a little less flexible. Amazon, on the other hand, took a different approach with Trainium. Instead of one giant factory, you can think of it more like a cluster of smaller, more adaptable workshops. This design actually lets their chips handle a wider variety of jobs pretty effectively, from training to inference. Okay, so up until now, we've been talking about these monster chips sitting inside massive data centers. But the universe of AI chips is expanding, and it's expanding right into the devices that we all use every single day. So say hello to the NPU, or Neural Processing Unit. Now, this isn't some separate giant chip. It's a much smaller, dedicated AI engine that's built right into the main processor of your smartphone or your laptop. Its whole job is to run AI tasks right there on your device without ever having to call out to the cloud. And this is a huge deal for a few really important reasons. When AI runs on your device, your data stays private right on your phone. The response is instantaneous because you're not waiting for a signal to go to a server and come back. And it's way, way more power efficient. This is exactly why companies like Apple, Qualcomm, and Samsung are pouring billions into their own NPUs. But the ecosystem is actually even bigger than that. You've got things like FPGAs, you can think of those as reconfigurable chips, kind of a middle ground between a flexible GPU and a rigid ASIC. You have these critical design partners like Broadcom, who are kind of the secret weapon helping giants like Google build their chips. And of course, you've got AMD, Nvidia's main rival in the high-end GPU market. It is a very, very crowded field. But here's the thing. Designing a world-class chip is really only half the battle. Actually, manufacturing these incredibly complex little pieces of silicon with features that are measured in nanometers, well, that's a completely different challenge. And it's one with massive geopolitical implications. You see, for decades, the most advanced chip manufacturing in the world has been concentrated in one place, Taiwan, and with one company, TSMC. But that is changing, and it's changing fast. Through huge investments like the CHIPS Act, the United States is working aggressively to bring that manufacturing back home, turning places like Arizona into a new global hub for making these chips. But there is a huge, looming problem hanging over this entire industry. All of these new chips and all of these new data centers, they require an absolutely astronomical amount of electricity. The demand for AI computing power is just skyrocketing, but our energy supply is not. Finding enough power is quickly becoming the next great bottleneck in this whole AI race. So, where does all of this leave us today? This chart is a great little snapshot. Nvidia is still the dominant force, there's no question about that. But that slice of the pie for custom ASICs built by the tech giants, it is growing incredibly fast. AMD is still a key competitor, and all those other specialized chips are carving out really important roles in niche areas and, of course, on our devices. And this right here is really the key takeaway. While it's going to be incredibly hard for anyone to dethrone Nvidia, the market for AI is just expanding so quickly that there is plenty of room for a lot of winners. The pie is getting so big that we're going to keep seeing more and more companies jumping into the race. Which leaves us with one final and I think really fascinating question. As AI becomes woven into basically everything we do, is the future going to look like the past with one dominant type of chip like Nvidia's GPU ruling everything? Or is the future going to be powered by a rich, diverse ecosystem of all kinds of different chips, each one perfectly designed for its own unique job? Thank you for watching. This is where we teach you AI and help you get smarter than your competition. To continue learning with us, please subscribe to the AI for Career Success YouTube channel. Liking, commenting, and sharing this overview helps us reach a wider audience.